You ever stop and think about that mysterious box in your neighborhood that just, makes the internet happen? Well, today we're cracking it open. We are unboxing the command center of your digital world, a piece of tech called the GPON OLT. Let's dive in. Now, really, just think about that for a second. One single, tiny thread of glass, and it's pumping 4K movies, intense online games, and all our video calls to hundreds, if not thousands of homes at the exact same time. How does that work? Well, it's not magic, it's coordination. And all of that coordination comes from one central spot. And this is that spot, the GPON OLT, which is short for optical line terminal. And look, this thing isn't just a simple switch. It's the brain. It's the air traffic controller. It is the absolute heart of the whole network. It's the one piece of hardware that tells everything else what to do. So here's our game plan. We're going to get hands-on. First, we'll make contact and log into this thing. Then we're going to build the network's foundation right from scratch. After that, we'll get into the fun stuff, controlling traffic, managing all the connections out to people's homes, and finally, we'll cover the essentials for just keeping the whole system healthy and running. Okay, first things first. Before you can command this network, you got to get in the door. And that means physically connecting to the OLT and learning how to speak its language. And the process is actually way more straightforward than you'd think. An engineer literally just plugs a laptop right into a special port on the OLT. They pop open a little terminal program, basically just a black window with text, and they dial in a few very specific settings. The OLT boots up, they log in, and bam, they're inside the command line interface, the CLI, and that is where all the magic happens. And these settings right here, they're basically the secret handshake. The speed it talks at, how the data is structured, every single little detail has to be perfect. It's kind of like tuning an old radio to a very specific hidden frequency. If you're off by just a little bit, you get nothing but static. But when you nail it, the OLT gives you the keys to the entire kingdom. All right, we're in. But right now, we're just standing inside an empty box. So the next move is to build the actual infrastructure inside the machine, these virtual highways that are going to carry all of our data. And we build those highways using something called VLANs, or virtual LANs. So imagine the whole network is one giant physical road. A VLAN lets you basically paint separate lanes on that road for different kinds of traffic. So you can have one lane just for internet, a totally separate one for TV, and another one for phone calls. They're all using the same physical road, but they're completely walled off from each other. It's super secure and really efficient. Now, these virtual highways have different kinds of on-ramps. You've got trunk mode, which is like a massive multi-lane superhighway interchange. It's built to handle traffic from all the different VLANs at once, connecting out to the wider internet. Then you have hybrid mode, which is more like a flexible local exit. It can handle a single car going to one house, or say, a bus that's carrying traffic for a whole bunch of different destinations. So we've built our virtual highways. Awesome. But, roads without rules are just total chaos. So now we have to become the traffic cops. And maybe more importantly, the bouncers, to manage the flow, spot any problems, and keep the whole thing secure. And one of the coolest tools for this is something called port mirroring. So let's say a customer's having a really weird connection issue. The engineer doesn't have to guess. They can use this feature to make a perfect secret copy of all the data flowing to and from that customer's connection, and then send that copy over to a diagnostic computer to see what's going on. And the best part? The customer has no idea. Their service is never interrupted. Setting this up is a really simple two-step dance, and you don't need to be a coder to get the logic. First, you tell the OLT where to send all the copy traffic. That's your destination port. And then you tell it which traffic you want to copy. That's your source port. It's clean, it's simple, it's logical. Okay, but what about security? This is where access control lists, or ACLs, come into play. The best way to think of an ACL is like a bouncer at a super exclusive club. It has a very strict guest list. When a little packet of data shows up, the ACL checks its ID, its source address, where it's trying to go, and it decides right then and there, are you on the list and allowed in, or do you get bounced? And that bouncer's guest list can be unbelievably specific. You can set up a simple rule that just blocks traffic from one specific place. Or you can get way more granular and have it check the destination, the type of traffic, even the specific port number it's trying to use. You can even block a device based on its unique physical hardware address. It's all about having layers and layers of control. Okay, so far we've been focused inside the OLT. Now let's kind of zoom out. Look out from the command tower and see how this thing manages all those individual modems, the ONUs, that are sitting in every single customer's home. This right here is where the mind-blowing power of the OLT really comes into focus. Just think about it. From this one central box, the internet provider can remotely manage the device that's sitting in your house. They can upgrade its software while you sleep. They can reboot it if it's acting weird. They can even change your Wi-Fi password for you, all without anyone ever having to visit your home. It is an absolutely incredible level of efficiency and control. But I mean, with thousands of devices all connected, what happens when one of them just goes rogue and starts causing trouble for everybody else? Well, that's what the industry calls a rogue ONU. It's a device that's not playing by the rules. Maybe it's broken, maybe it's unauthorized, but it's basically shouting out of turn in a quiet library, making it impossible for anyone else to communicate. But the OLT is always listening. It can automatically detect that noisy device and just snip. It cuts it off from the network instantly, protecting service for everybody else. The network literally heals itself. All right, last section. So building the network is one thing, but keeping it running day in and day out, that takes constant care and feeding. This is the ongoing housekeeping that, well, keeps the internet on for all of us. So to keep the system healthy, engineers are always checking its vital signs. They're making sure its processor isn't getting overloaded or checking that the optical light levels are strong and clear. But after all of that work, all that configuration, there is one command that is more important than all the others. Write. That command saves everything. Forgetting to do that is the classic rookie mistake. Hours of work can just vanish into thin air the next time the system reboots. And this quote, which is pulled straight from the user manual, it just perfectly sums up what it's like to work with this kind of hardware. It is a world of absolute precision. The machine does exactly what you tell it. If your command is syntactically perfect, it works. If it's not, you get an error. There is no in-between, which is what makes it so powerful, but also so unforgiving. So from logging in with a secret handshake, to building virtual superhighways, to acting as a nightclub bouncer for your data, the GPON OLT is truly the unsung hero of our connected lives. The next time you hit play on a movie and it just instantly appears on your screen, maybe you'll give a little nod to that invisible command center out there, making it all happen. Thanks for tuning in.